Okay, what we're going to do now is very similar to what we did last time. Still dealing with the first derivative test, only now we're going to go deal with trig functions. Now, this is the same set of rules we did last time, so keep that handy. The sheet of the rules or the steps if you're still not familiar with them. But one big difference is that instead of going from negative infinity to positive infinity, now you are dealing with a periodic function, the same thing over and over and over again. Which means that we have to restrict our interval to something else rather than to infinity. So most, if not all, the problems that we're dealing with in trigonometry will go from 0 to pi. Now maybe possibly the tangent functions will be for pi, but the cosine and sine and secant and cosecant will all deal with pi. And anyway, they'll give you the interval that you need to be concerned with. So the first thing we do, like we did before, is we find the derivative of this. Derivative of x over 2, that becomes 1/2. Minus, because it's the opposite of positive sine x, so it's negative sine x. And that is our derivative. So what we're going to do, we're going to set that equal to 0 to find the critical points. So that means then if I move the 1/2 over here, it's negative 1/2 equals negative sine x. And these will get rid of the negatives by multiplying both sides by negative 1. And we get sine of x equal to 1/2. Well, when does that occur? That occurs when x is, well, if you think of it in terms of degrees, it's 30 degrees. If you change that over to radians, that becomes pi over 6 radians. It's also positive in the second quadrant, so but in that case it's going to be pi over 6 radians away from the pi, or 30 degrees away from the 180 degrees to 150 degrees, or 5 pi over 6. So these are your two answers, which means then these are your critical numbers. Those are the i's and x in which we are going to see the change. So these are going to be either a maximum or a minimum, or neither, depending on what's going on. So, find the critical point. We're going to take this right here and plug in the pi over 6 first for that. So, pi over 6 over 2 plus cosine of pi over 6. Plug that in your calculator, and the y value for the x value of pi over 6 is 1.13. So the critical point becomes pi over 6 and 1.13. Now if you want to put that in decimal form, understandable, don't have to, but that's fine. The other critical point will come from the x value of 5 pi over 6. So we plug in the 5 pi over 6 for these. 5 pi over 6 over 2 plus cosine of 5 pi over 6. And we get for value for that, we put that in the calculator, of 0.443. So this gives you 5 pi over 6. 0.443. Now one of these is going to be a relative minimum, the other is going to be a relative maximum, and that will depend upon what happens with the three intervals that we're going to deal with. Y3 is going to have the interval before this up to 0, between these two values, and from, 0 to pi over 6 rather, and then pi over 6 to 5 pi over 6. Where I have, oh yeah, right there. And then from 5 pi over 6 to 2 pi. All right, so let's do the first one, from 0 to pi over 6. Okay, so interval 1 from 0 to pi over 6. And we're going to pick, we're going to pick a number between that. We're going to test this to see if we get a positive value or negative value, see if it's increasing or decreasing. So this is going to be, I'll take what, half of this right in the middle, so that means you just divide the denominator by 2, get your pi over 12. And then plug that in for my value for f prime of x. Because the derivative will tell you if it's positive or negative, if it's increasing or decreasing. So that means then that 1/2 minus the sine of pi over 12 equals, I get for that 0.241. That's positive. That means that this is increasing. Okay, the next interval is going to be from pi over 6 to 5 pi over 6, so interval 2, pi over 6, 5 pi over 6. So I'm going to test with a number in the middle of that, and I believe I tested with pi over 3, okay? It doesn't really make any difference. You're going to get the same sign of answer no matter what. So this is 1/2 minus the sine of pi over 3. And the answer I get for that is negative 0.366. Negative means it's decreasing. So now we see that it's increasing from 0 to pi over 6, and then it's decreasing to the next. So that means the critical point is going to be at the top of that hump there, and that's going to be a relative maximum. So that first critical point will be a relative maximum. The third interval is going to be from 5 pi over 6 to 2 pi. And I'm going to use pi because it's really easy to type my calculator, so I'm going to test pi, and it is between these two values. So 1/2 minus sine of pi. And I get for an answer there of positive 0.5. And in fact, if that's positive, it means that this is increasing. So this is just the opposite of what was happening here between these two right here. So that makes this critical point the relative minimum. Okay? I'll do one more just to make sure you see the process, but it's not a whole lot different from before. You're still using the calculator to figure your numbers for your critical points and critical numbers. So nothing too challenging out of this. So let's do this one here, number 41. This